Hello, everybody. Hope you are doing well. Thank you for being here today and joining in our webinar. So, it's me, Mỹ Nguyễn again. I am a BIM developer on the software development team. And in the previous webinar, I have shared you about information about our Python part for wall and column reinforcement. And today, in the last webinar, our series about Python part for building reinforcement for ALLPLAN software, I will show you how to use our beam reinforcement Python parts. At the beginning, I will talk about beam reinforcement and Python part for this job in ALLPLAN software. And next, I will show you in detail how to use our beam Python part to reinforce a beam in ALLPLAN. And finally, if you have any question, please let me know. I will spend about 20 minutes to answer them in Q&A session. Beam reinforcement is a feature of our building reinforcement Python part package in ALLPLAN software that let you create, update, and modify reinforcement for beam from single to continuous one, complex one in ALLPLAN. And placement reinforcement, support rebar, and startups based on the rules you set in the configuration. And man rebar can have a multi-top, bottom, and center rows. Tie selected man bars with startup, which can be different sets, and distribute them along the beam, extending outside the beam if needed. And with the beam reinforcement Python part function, pose section and label style can be defined quickly, and that means production of drawing will be faster, and we can also avoid mistakes. So, don't let you wait too long. I will open ALLPLAN software and introduce you in detail how to use onto beam reinforcement Python part. So can you see my screen share? Okay. So here we have ALLPLAN channel 2, and this is onto Python part and beam reinforcement Python part. So firstly, I have a beam here, and as you can see, the beam will model at a continuous beam. And with the beam reinforcement Python part, we can separate this beam into two spans and define to create reinforcement for these two beams separately. So, as you can see, we have a column and a wall adjacent with this beam. So I want to create reinforcement for this beam adapted to this column and wall. So now I will show you how to do that. First step, double click to the beam reinforcement Python part icon, and then I will select the beam, and then press escape button. Next step, I will select the column that cut the beam to divide this beam into two spans. And next, I will click to select the column and wall that are adjacent to this beam. This step we have to recognize the column and the wall adjacent to the beam to create an offset to make the reinforcement adapt to this wall and column. Then I will press escape button to open the beam's interface. And as you can see here, we have a beam reinforcement Python part interface The same with the wall and column reinforcement Python part. We have a friendly interface that contains a lot of tabs, as you can see here. We separate function to define the parameter for each type of rebar. So now in the top main tab, I will define to create a Python part element. Create a Python part element will help you to have an ability to double click to open this Python part interface again and modify the reinforcement once again. So firstly, I will define the top main rebar. Here we can select the quantity and parameter of the top main rebar. And we can add some extra main rebar here. And we can define to create maximum 3 layers. Here we create 2 layers of top main rebar. With the same parameter. And here we have options to define parameter for top main rebar like hook length, hook angle, concrete cover, and overlap position and overlap length. So next I will go to the bottom main tab and define the same for the bottom main rebar. Okay, I will now click to the create beam reinforcement button to create. And as you can see, here is the result. You can see here we have a top main rebar and bottom main rebar with extra rebar and 2 layers were created. And the reinforcement also adapt to the adjacent column and wall. You can see. And next, I have a beam with 3 separated spans here, as you can see. And this span have a different depth, or we can say have a different elevation bones. And I want to create the bottom main rebar can be automatically cut and lap or bend with my condition. So how can I do that? I will show you now. Same step, double click to the icon. So the next step, I click to select all the span and right escape button. Then click to the first and the last column, the adjacent column. With this beam, I don't need to click to the column that's cut the beam because it's created with separated 3 span separated. So right escape button to open the Python part interface. And next I will go to the bottom main tab, and here is the option to define to crank rebar if it needed with the condition here for ground rebar. And this is the number box to define the length, the lap length, in case the bottom man rebar cut and lap. I will write here 17 centimeter. Okay, click the right button. Okay, and as you can see here, the bottom man rebar can cut and lap or bend with the condition we set. You see? So, next step, I will add some startup to this beam reinforcement. So we'll populate to the PythonParts element to reopen the PythonParts interface. You can see. And go to the startup spacing tab here to define the startup spacing. One thing that I want to know here is the startup spacing can be defined the same for all span when you tick the digit box, or define separately for each span by define one and then click to the next span to define, and click to next span to define. Here I will define the same for all span. And as you can see, we have ability to define, to create the startup with 3 placement, maximum 3 placement of startup. When we tick to this checkbox, and here we have a number box to define the spacing for each placement. Example, 15 centimeter. Yeah. 25 centimeter here. And the length of each span can be defined based on 3 options. The first is the length of the beam. And the length of the beam can be counted from the center of the column or from the edge to height of the beam. You can see here. And the placement length can be defined by on the beam length. You can see. And in some case, we have to define the placement length based on the beam depth, or we can say beam height. Click this and define the radius of beam depth. So first step, I will go to the startup tab to define the general, to define the create the general startup with this button. And as you can see, it is the general startup. And define parameter for this startup, like diameter, hook length, and hook angle. Okay, we click to this button to create startup for this beam. So as you can see, we have a result here. The startup will create in 3 placements, which we will set, as you can see, and separately in 3 spans. Different length and different spacing. So in some case, we need to create a setup at a custom set. What? How can we do? I will show you by double click to this PythonPart element. Continue to go to the startup tab, and here I will clear the general startup. Okay, firstly I will go to the top man to remove some unnecessary, define the top man rebar again to help you have a better look. So, okay, so here in the startup tab here you can see we can define to create a custom tab by click from 1 to draw all the tab of the startup. The same for this tab. And as you can see, here we have a custom set of the startup here. And in some case, we also need to play the first startup exactly, example, 5 centimeter from the column. So we can go to the startup spacing, and here we have an option. Click to this startup offset, and here we have a number box to define the distance from the first startup here to the column here. Okay, I will click to create and show you the result. And you can see the result here. We have a custom set of the startup. And here we have the distance from the first startup to the column is exactly 50 millimeter. So here now I will show you how to add some extra middle rebar or extra beam for this beam reinforcement. So I will double click to the PythonPart element, and go to the startup tab. Here you can see we have an option to include middle rebar and define the number of layer of middle rebar, 5 layer maximum, and define the diameter. And we can also extend this middle rebar to the column. And this is an option to add extra beam. Here, as you can see, the extra beam appear here. And I will define the parameter for this extra beam. Okay, and click to create. So, as you can see here, we have the middle rebar and extra beam here. And now I want to add some additional rebar for this beam. So we click to this PythonPart element and go to additional tab to define the additional rebar for this beam. So as you can see here, we have the maximum 3 layer of additional rebars is supported. Here I will define the number of bar in one layer and the parameter for additional rebar. top additional rebar, and this is for bottom additional rebar. And to define the length of additional rebar, we have 3 options. Define by value, input value here. Sample. Or by diameter, the radius of diameter, or by beam length. Beam length can be defined to count from the middle of the column. You can see the center of the column, or from 2 heads of the beam. That's the beam length. See, so here I will define define this length by on the value. And to define for the next one, I will click to this button to go to the second one and do the same step. 120 diameter, 120 diameter. Go to the next one, 120 diameter, 120 diameter, and the length. Okay. So click to create. And as you can see, we have additional rebar here. For X-band, additional rebar for X-band here. And in some case, or we can say in some standard, we want to create this additional rebar to the same layer with the main rebar. How can we do that? Okay, we show you. Look, click to the PythonParts element and additional tab. Here we have an option to define the distance from the additional rebar to the top main rebar. The distance of 2 layers, between 2 layers. Or we can take to the checkbox to define, to create the additional rebar in same layer with main rebar. You can see. So as you can see here, we have an additional rebar will create in the same layer with the main rebar. Okay. And the next, the question is, I want to create the spacer for this additional rebar to keep inside this. So how can I do that? Double click to open and continue to go to additional tab. And as you can see here, we have a checkbox that you have to use to create the spacer for this beam reinforcement. You see spacer. And here we can define the parameter for the spacer, like diameter and spacing. And then we define to the distance between 2 layers exactly equal to the diameter of the spacer. And click right? And here is the result. We have a additional rebar with spacer. You can see. Okay, go to the another case. Here we have a beam that was modeled separately from the slab above, but I want to create reinforcement for this beam adapt to this slab. So how can I do that? Okay, open the beam face. And a bottom man tab. As you can see, we have an option name with slab above. We can click tick to this checkbox and tie the slab height to define to adapt the reinforcement of the beam to the slab above. And as you can see at the selection step, we don't have any column, adjacent column or wall of this beam. So, but I want to create the reinforcement for this beam, adapt to this slab, as you can see. So we have an option for that. Name start offset and end offset. Here I will define to create with 40 centimeter, and click to this button. And as you can see the result here. We have the beam reinforcement adapted to the above slab and have offset at 2 head equal to the value we inputted. So now I will come back to the first model to show you how to create the sections of side view for this beam. Okay, I will open the PythonParts interface. Define the parameter for this again. No offset, no slab above. General startup. No spacer. Okay, to define the parameter for the section, we will go to the section tab. And the first step, we can define the beam name here. Click to this checkbox to add the title of the side view and click to the title button to define the description for this title. We can use the parameter button in the right side of the sub interface to define the title description. You can see I will add the beam name here. So when we change the beam name here, this name is changed to. And we can define the same with the wall and column reinforcement PythonParts. We can define the font style, and the size of the description. You can see here. And we can underline, isolate, or bold the description. Yeah. Okay, next I will click to the side button to save this setting, and we have the number box to define the distance from the title to the side view, the main, or we can set the main section. Click to add elevation bound and define the distance. Click to add the dimension line and define the distance. And this we have a true number box to define to create an offset for this side view. And the same for the section. Click to define, click to add, click to add title and define the title. You see, add elevation bound, add dimension line, and as you can see, we have the ability to set the width of the section here, and the name of the section here, and the name of the section will be start from the number or from the character we type in this box. Example, we type here 5. The section will be created 55, section 55, 66, 77, etc. Okay, so next step, I will click to this button to create section and click to a point in plan view to create the section. As you can see, here we have the result here. And we can define to create the number of session. We can control the number of the session for each band. How can do that? I will show you. Okay, go to the session tab, and here you can see we can define the number and the position of session with this checkbox. Untick to remove the middle section. Okay, and then we go to the second band. Just create the middle section for this band. And you can see here we have the result here. 2 sections for the first one and only the middle section for the second one. Okay. So next part, I will show you how to create this beam section with label from reinforcement to section with label. So first step, I will turn on the reinforcement and the section drawing. Open the interface. And the first step, I will go to the section tab to remove some unnecessary. See here. And next, I will go to the label tab. Here we have a number box to define the distance from the label to the section. The same for this. And here, click to this button to define the label option. Like here, I will add the steel right for the label. The same for this. We click to this button and select the drawing will contain the reinforcement. Then select the drawing will contain the section. And as you can see here, the reinforcement were created. And next step, I will click to a point in plan view. To create the section with label. And next step, I will refresh this label and section. To apply them at the right position. You can see here we have the result. So that's all for our beam reinforcement Python part. Now I will show you how to use a specific Python part for a precast beam which we develop for our customer. And this Python part can help to create from 3D model to a reinforcement and section with label. This will help you to save a lot of time. Okay. And you can see here we have a precast beam here. And this is our Python part for this precast beam Python part. Click to open the interface. Click the button to get the geometry from this beam. And as you can see, we can get all the dimension of the beam. Or if we don't have any beam model, we can define the beam parameter for the dimension beam parameter and then click to this button to create a beam model. As you can see, we have a new beam model here, which we just created. Okay, now I will show you how to write reinforcement for this beam. I will go fast because we already have a tutorial for this beam recast on our YouTube channel. You can find and watch full carefully. Go to the startup. Here you can see we have ability to define 7 placement of the startup with different spacing. Define the startup parameter here and go to the main rebar tab to define the main rebar. See. And click to create reinforcement for this recast beam. You can see we can create reinforcement for this beam with just some click. And one more thing, the Python part can automatically recognize and create the incline rebar. And you can see this is the incline rebar with the top hook or not. based on the length of the two heads, as you can see. So next step, I will create a section with label for this beam. I will double click to the Python part, go to the section and label tab, define all the parameter, click to this button, select the drawing content rebar, select the drawing content section, and a special thing in this Python part that we can set the scale of the side view first and click to a bones in plan view to create the side view, and then we set the scale of the section and then click to create the section, and as you can see we have a result here. The section and side view will create in different scale. You can see. So once again, thank you for being here today and joining our webinar series. Hope you have a nice day and goodbye. See you again.